All right, example 5. It's the same type of problem we did yesterday, except it's not in standard form, it's in general form. So just like the other kind of sections we've dealt with, we're going to have to change to a standard form. And one thing, every time I'm telling you what they are, but just know as far as characteristics of an equation, it says graph the hyperbola, so obviously hyperbola. But if it didn't tell you it was a hyperbola, you'd be able to identify it as a hyperbola because x and y are both squared and the signs are opposite. All right? And one point of caution on these problems, do not make an assumption at the beginning of this problem of which direction this hyperbola goes. Currently x squared is positive, y squared is negative. When I get to standard form, that's when I have to make the decision. Sometimes standard form, the signs switch around. So there's no way to tell just by looking at it what's going to be positive or negative when we get to standard form. Now the technique for getting standard form here resembles the technique we did for ellipses. The only difference is with ellipses, there's both positive numbers. In this case, we have a negative number, so it causes a couple sign issues that might show up along the way that have to be careful about. So the first step, if we're trying to get this standard form out, is we want to group our x's, group our y's, and move the numbers. So I want x's and y's on the left, numbers on the right. So I'm going to put 4x squared minus 8x together, because they're both about x. Leave a little bit of space. Then negative 5y squared plus 20y together. Leave a little bit of space, equals negative 4. I want an x group over some number, a y group over some number equal to 1. So the first step is to get the x grouped together, the y's grouped together, and the numbers to the other side. The second step, very, very important step, this has to be 1x squared, this has to be 1y squared. There's no way around that. It has to be. So if there's a number in front of either x squared or y squared, we must take that number out. So in front of x squared there's a 4, so I'm going to take a 4 out, put a parentheses. And I want these two guys here to go into the parentheses correctly so that we took a 4 out of both objects. So 4x squared divided by 4 makes positive 1x squared. Negative 8x divided by 4 makes negative 2x. Okay. Same idea happens here. This is negative 5y squared. I just want y squared. I don't want negative 5y squared. So I have to take a negative 5 out. And all this stuff has to go inside the parentheses correctly. And what I'm doing is I'm taking a negative 5 out. That's division by negative 5. So negative 5y squared divided by negative 5 makes positive 1y squared. Again, what we wanted to happen, right? Okay, in the first place where people tend to mess up on these problems is about to happen here in a second. I'm taking 20y, positive 20y, dividing by negative 5, which makes a negative 4y. Be very cautious with the sign of the second term. Again, we are extracting a negative there. So negative divided by negative makes a positive for y squared. Positive divided by negative makes a negative for y. And all that stuff has no effect on the number on the other side as of right now. Okay. So that's our next priority. We want x squared in the parentheses. We want y squared in the parentheses. Any numbers must be extracted. Divide both objects by that number. Next step is we're going to complete the square. All right, I'm going to use a couple different colors so you see where things are coming from. All right, completing the square is what it has been inside the parentheses. So I'm going to take half of 2, which is?
2.
Half of 2 is 1. And then 1 squared is? 1. So I'm going to add 1 here. But adding 1 inside the parentheses is in reality adding 4 times 1. So I've actually added 4 to that side. So I have to add 4 to this side as well. So again, you're adding a 1 inside the parentheses. The parentheses is being multiplied by 4, so all content is being multiplied by 4. So the actual value change on the left is positive 4. We have to put a positive 4 value change on the right-hand side. Let's use orange for this. All right. Half of 4 is?
2.
And 2 squared is? 4. So I have to do plus 4 inside the parentheses. The actual value change to the right-hand side, though, is positive 4 times negative 5, which is negative 20. So I have to put a negative 20 on this side. Okay? So when you complete the square, you always put plus. Plus 1, plus 4. But then the actual value change is the number you put in there times the outside number for that group. That's how the other side gets modified.
So you wouldn't do it after you get like 4x minus 1 and then do 4 times 1? Because what I did is I you know, it's 4x squared minus 2x.
Mhm.
And then you have to do.
So you
4x
tried to do it
minus-
up here,
No, I tried to do it down one more step.
down here?
Like 4x minus 1, and then parentheses, and I did 4 times 1 that way. And then I did 5, and then y minus.
Oh, so you tried to
4.
factor it first,
Yeah.
then deal, yeah. When you put the number in, you gotta put the number over. So, in the same line here, you wanna do that at the same time, absolutely. So you took the square root of the number, then multiply out, you gotta multiply first. So in this step, so again, it's all about value change. We're doing an algebra step here. We're changing the value on the right-hand side, or sorry, the left-hand side by some amount. We have to change the value on the right-hand side by the same amount in the same step. So I made the plus 4 happen here, so I have to make the plus 4 happen there. Minus 20 to minus 20. All right, so at this point, I'm going to factor. So I've got my parentheses squared here, and I got my 4 out in front. All right, so keep in mind to get the contents here. Some of you are doing this wrong, and I'm just going to give you the checklist real quick. We want a sign, or sorry, we want a letter. We want a sign, and we want a square root. All right, there's 3 objects: object 1, object 2, object 3. All right, the letter comes from the first object, the sign comes from the second object, the square root of the third object is what we want. All right, so the letter we're going to use is x, the sign we're going to use is minus, the square root of 1 is 1. I think the reason that some of you are doing this wrong is because square root of 1 is 1, so it looks like I just put that number there. But I actually took the square root of 1 equals 1. All right, and then on the second one here, I've got minus 5 parentheses squared. Again, I want a letter, the letter's y. I want a sign, comes from the second term, that's minus. I want a square root of 4 is equal to 2. A lot of you are putting 4 here instead of 2 here. So again, square root of 1 is 1, the square root of 4 is 2. We're taking the square root of the number to get that factored form. And then on the right-hand side, if I just add up my numbers, negative 4 plus 4 is 0, minus 20 is negative 20. Next step is now divide everything by negative 20 because we want it to equal 1. So again, I'm trying to create a standard form. Standard form for the hyperbola and the ellipse also both have equals 1. So divide by negative 20, divide by negative 20, divide by negative 20. Now, you remember with the hyperbolas, the order of the standard form matters. If y squared is first, it's up, down. If x squared is first, it's left, right. And whatever is first is the positive one. So what I'm going to determine the sign about is, what I'm looking at here specifically is what's outside the parentheses. So 4 and negative 20, negative 5 and negative 20. All right? If I divide these, what kind of sign do I get?
Negative.
And these I get a positive. So this ends up being my positive object, this ends up being my negative object, so I'm going to swap the order as I do the division. All right, so my final step here in creating the standard form is to get, I'm going to get parentheses, y minus 2 squared over 4 minus parentheses x minus 1 squared over 5 equals 1. Okay. So again, this makes a positive 4 on the bottom. Since it's positive, I put the y minus 2 squared in front. This makes a negative 5 on the bottom. So since it's negative, I put minus here. I don't put the minus on the 5, but the minus in front. Let 5 be on the bottom. So that's still the minus 5 happening, but the minus is out in front. So that second equals 1. That equals 1 over there. Right? So that is how we create standard form. And again, the technique is almost identical to the ellipse technique. The only difference is there's some sign issues you have to be focusing on. And again, order matters on this. So make sure you create the order that matches what we're looking to do. Once we get standard form, this is the exact same type of problem as yesterday was. So we're going to find the center, find A, B, and C, find the slopes of asymptotes, put the 5 points and the 2 asymptotes on, and connect the dots. All right, so the center is H comma K. What is H in this problem?
4,
And what is K?
2.
2. Right. H is always with X, sign is wrong. K is always with Y, sign is wrong. So put HK order, make sure the signs are modified. This becomes positive, that becomes positive. Where is A squared always located? Under X. X is over here, so A squared is 5, which means A is equal to the square root of 5, which is 2.24. Where is B squared always located?
Under Y.
Under Y. And Y is here, so B squared equals 4, which means B is equal to the square root of 4, which is 2. And c squared is just the sum of these two numbers. We add them up, 4 plus 5 is 9, which means c is equal to 3. What type of hyperbola is this, up, down, or left, right?
Up, down,
Up, down, because
y is positive.
the y is positive, which makes it up, down, which means that we care about b, up, down to get 2 points, and c, up, down to get 2 points, 2 vertices, 2 foci. A does not come into play for plotting points. And finally, my slopes of asymptotes, SOA, is going to be positive 2 over 2.24 and negative 2 over 2.24. I'm going to write it like that instead of the plus minus. I think that was confusing some people yesterday. So we have a positive slope, we have a negative slope. Imagine the positive signs on top, imagine the negative signs on top. The bottom number is always positive. So when I'm looking at my slopes of asymptotes, the top number is either up or down. The bottom number is, I'm going to be going right every time. So positive over positive, positive up, positive right, negative over positive, negative down, positive right. So if you make sure that bottom number is always positive, you're always going right. You just have to worry about the up and down. I think that's the easiest way to deal with it. So if I plot everything I know, my center is 1, 2, so I'm going to put a dot at 1, 2. I'm going to go up and down 2 spaces to get to vertices from my center. So 2 spaces up is right here. 2 spaces down right there. There's my 2 vertices. We go up and down 3 spaces for my focal points. So I go from the center up 3, from the center down 3 to get my 2 focal points. For my 2 asymptotes, I've got a positive 2 over 2.24. From the center, go up 2, go right 2.24. And for the down one, I'm going to go down 2, right 2.24, creating my 2 slant asymptotes. Make it purple. So I got a purple one. Like so. And I like to draw it so that, you know, I want the asymptote to go beyond the vertex here, so I got to kind of extend it. So if the graph paper kind of ends, I want to extend it far enough. So here's my vertex. I want it above the vertex a little bit. Then I got my green slant asymptote as well, right here. And it goes through the center, and it goes through the point that we created with the slope. So there's my 2 slant asymptotes. And then I simply have to connect the dots. I want to start at the asymptote, go through the vertex, end at the asymptote. So it's going to be near the asymptote, come through like this, and go back up towards the asymptote. And the same thing down here, going up through the vertex, letting the graph hug on the asymptote.